Econometrics 106 MCQs with answers, noun exam practice and revision. Welcome to this comprehensive ECO355 Econometrics multiple choice question, MCQ, practice guide designed specifically for noun students and anyone studying econometrics at undergraduate level. This video, or resource, covers over 100 well-structured MCQs drawn from key topics in the course, designed to help you understand, revise, and prepare effectively for exams. Each question tests your knowledge of econometric theory, assumptions, estimation methods, and model applications. Blue Book topics covered. 1. Introduction to econometrics. 2. Simple linear regression and least squares. 3. Statistical inference and OLS properties. 4. Classical linear regression model, CLRM, assumptions. 5. Maximum likelihood estimation, MLE. 6. Normality tests, Jarque-Bera, Histogram, NPP. 7. Econometric theory and methods. 8. Modern versus financial econometrics. 9. Importance and applications of econometrics. 10. Co-integration. 11. Autocorrelation. 12. Heteroscedasticity. Kindly watch the video to the end. Let's get started. Blue Book Section 1, Introduction to Econometrics, 10 MCQs. Q1. The term econometrics is derived from which combination of words? A. Economics and arithmetic. B. Economics and mathematics. C. Economics and measurement. D. Economics and statistics. Answer. C. Explanation. Econometrics comes from econo, economy, and metrics, measurement. Q2. Econometrics is primarily concerned with A. Theoretical economic concepts only. B. Statistical description of economic data. C. Measurement and testing of economic relationships. D. Mathematical optimization of business processes. Answer. C. Q3. The field that provides the mathematical structure for econometric models is A. Economics. B. Statistics. C. Mathematics. D. Accounting. Answer. C. Q4. Which of the following statements best describes theoretical econometrics? A. Application of econometric methods to real data. B. Development and testing of new econometric techniques. C. Collection of economic data for modeling. D. Estimation of economic indicators. Answer. B. Q5. Applied econometrics mainly involves A. Developing new estimation formulas. B. Using econometric methods to study actual economic data. C. Predicting global weather changes. D. Formulating abstract economic theories. Answer. B. Q6. Which of the following statements is true about financial econometrics? A. It only deals with non-financial data. B. It applies econometric techniques to financial market data. C. It is unrelated to time series analysis. D. It ignores volatility and risk. Answer. B. Q7. The main difference between modern econometrics and financial econometrics is that A. Modern econometrics focuses on applying statistical methods to financial data. B. Financial econometrics applies statistics to general economic behavior. C. Modern econometrics uses mathematical and statistical models to analyze any economic phenomenon. D. Both are the same. Answer. C. Q8. Which of the following best explains the importance of econometrics within economics? A. It replaces economic theory. B. It provides numerical estimates and tests the validity of economic theory. C. It focuses on data collection only. D. It discourages the use of mathematics. Answer. B. Q9. Econometrics is most closely related to which of the following fields? A. Accounting and management. B. Statistics and mathematics. C. History and sociology. D. Geography and anthropology. Answer. B. Q10. A major limitation of econometric analysis is that A. It is always correct. B. It can establish causation without theory. C. It may show correlation that is not causal. D. It cannot use data. Answer. C. Green Book Section 2, The Econometric Model, Simple and Multiple Regression. Covers regression concepts, assumptions, estimation, and interpretation. Total, 15 MCQs. Q1. In a simple linear regression model, y equals beta underscore 1 plus beta underscore 2x plus u. The term u represents a. the dependent variable b, the independent variable c, the disturbance or error term d, the constant term answer. See explanation. U, the disturbance term, captures all other factors affecting y that are not included in the model. Q2. In the model, y equals beta underscore 1 plus beta underscore 2x plus u. The parameter, beta underscore 2, measures a. the intercept of the regression line b, the average change in y when x changes by 1 unit c, the variance of x, d, the total sum of squares answer, b. Q3. The ordinary least squares, OLS, method estimates parameters by a. minimizing the total of observed values, b. maximizing the probability of error, c. minimizing the sum of squared residuals, d. maximizing the correlation between x and y answer, c. Q4. The OLS estimators are called blue because they are a. best, linear, unbiased, efficient, b. best, limited, unbiased, exact, c. best, linear, uncorrelated, efficient, d. basic, linear, unbiased, estimators answer, a. Q5. Which of the following is not an assumption of the classical linear regression model, CLRM? A. The error term has zero mean, b. The independent variable is stochastic, c. The variance of the error term is constant, d. The error term and independent variable are uncorrelated answer, b. Q6. The OLS estimator of beta underscore 2 in the simple regression model is given by beta underscore 2 equals \frac sigma x underscore I \bar x y underscore I \bar y sigma x underscore I \bar x caret 2. This represents a. the slope of the regression line, b. the intercept term, c. the sum of squared errors, d. the residual value answer, a. Q6. The OLS estimator of beta underscore 2 in the simple regression model is given by beta 2 equals sigma x minus x y minus y / sigma x minus x superscript 2. This represents a. the slope of the regression line, b. the intercept term, c. the sum of squared errors, d. the residual value answer, a. Q7. In regression analysis, the error term, u, captures a. the perfect prediction of yb unobserved or omitted factors that influence yc. The deterministic part of the model, d. The effect of x on y answer, b. Q8. The coefficient of determination, r squared, measures a. the proportion of variation in y explained by xb. The total correlation between x and yc. The average prediction error, d. The sample variance of x answer, a. Q9. If r squared equals 0.85, it means that a. 85% of variation in x is explained by y, b. 85% of variation in y is explained by xc. The correlation between x and y is 0.85d. The regression model is not significant answer, b. Q10. The OLS estimators are consistent, meaning that a. they always produce identical estimates in all samples, b. as sample size increases, estimates approach true parameter value, c. they depend on the scale of measurement, d. They cannot be biased answer, b. Q11. Which of the following properties is true under the normality assumption? A. OLS estimators are nonlinear, b. OLS estimators are biased, c. OLS estimators are minimum variance unbiased, efficient, d. OLS estimators cannot be used for hypothesis testing answer, c. Q12. The error term, u underscore I, in CLRM is assumed to have a. constant mean and increasing variance, b. zero mean and constant variance, c. constant mean and non-constant variance, d. random mean and random variance answer, b. Q13. The method of maximum likelihood, ML, estimates parameters by a. minimizing squared residuals, b. maximizing the probability, likelihood, of observing the given sample data, c. minimizing total error variance, d. maximizing the number of parameters answer, b. Q14. Under normality, the OLS and ML estimators of regression coefficients are A. Different in small samples but identical in large samples. B. Identical under normality assumption. C. Unrelated. D. Equal only when beta equals 0. Answer B. Q15. The Gauss-Markov theorem states that A. OLS estimators are blue under CLRM assumptions. B. OLS estimators are biased and inconsistent. C. OLS estimators minimize correlation. D. OLS estimators have maximum variance. Answer A. Green Book Section 3, Hypothesis Testing and Inference in Econometrics. Covers t-test, f-test, confidence intervals, and decision rules. Total, 14 MCQs. Q1. In hypothesis testing, the statement we aim to test is called A. Alternative hypothesis. B. Critical hypothesis. C. Null hypothesis. D. Regression hypothesis. Answer C. Q2. The null hypothesis, H_0, usually represents A. A claim that there is no relationship between variables. B. A claim that there is a significant relationship between variables. C. The most preferred alternative. D. The model's residual term. Answer A. Q3. The alternative hypothesis, H_1, is accepted when A. The t-statistic is less than the critical value. B. The p-value is greater than the significance level. C. The null hypothesis is rejected. D. The error term is 0. Answer C. Q4. The t-statistic for testing a regression coefficient is computed as t equals beta minus beta slash s dot e beta, where beta underscore I0 is A. The estimated slope coefficient. B. The hypothesized value of the coefficient under H_0. C. The sample mean of xd. The standard error of y. Answer B. Q5. If the computed t-value exceeds the critical value at 5% significance level, we A. Accept the null hypothesis. B. Reject the null hypothesis. C. Accept both null and alternative hypotheses. D. Redefine the regression model. Answer B. Q6. The p-value represents A. The probability of accepting a true null hypothesis. B. The probability of obtaining a test statistic as extreme as, or more extreme than, the observed value, if H_0 is true. C. The significance level chosen by the researcher. D. The probability of type 2 error. Answer B. Q7. A confidence interval gives a range of values that A. will always include the true population parameter. B. may contain the true parameter with a specified probability. C. depends only on the dependent variable. D. is determined solely by the sample mean. Answer B. Q8. A 95% confidence interval means that A. there is a 95% chance the sample mean equals the population mean. B. 95% of the sample data fall within this range. C. If repeated many times, 95% of such intervals will contain the true parameter. D. The true parameter changes 5% of the time. Answer C. Q9. The f-test in econometrics is typically used to A. test the significance of individual regression coefficients. B. test the joint significance of several coefficients simultaneously. C. measure autocorrelation in residuals. D. estimate error variance. Answer B. Q10. In a two-variable regression model, the degrees of freedom for the f-test are A. n2 for numerator and nk for denominator. B. k1 for numerator and nk for denominator. C. nk1 for numerator and k1 for denominator. D. n1 for numerator and k1 for denominator. Answer B. Q11. A type 1 error occurs when A. we reject a true null hypothesis. B. we accept a false null hypothesis. C. we accept a true null hypothesis. D. the sample size is too large. Answer A. Q12. A type 2 error occurs when A. we reject a true null hypothesis. B. we accept a false null hypothesis. C. we accept a true null hypothesis. D. we use the wrong test statistic. Answer B. Q13. The level of significance, alpha, is A. the probability of committing a type 2 error. B. The probability of rejecting a true null hypothesis C. The confidence level of the test D. Always equal to the p-value answer B. Q14. In econometric testing, if the p-value alpha, we, A, accept the null hypothesis B, fail to reject the null hypothesis C, reject the null hypothesis D, increase the sample size answer C. Section 4. Assumptions of the Classical Linear Regression Model, CLRM. The Classical Linear Regression Model, CLRM, is based on eight fundamental assumptions that ensure the ordinary least squares, OLS, estimators are best linear unbiased estimators, blue, according to the Gauss-Markov theorem. Q1. How many basic assumptions are contained in the Classical Linear Regression Model, CLRM? A. 5b, 6c, 7d, 8 answer, D. Q2. Which of the following is the first assumption of the CLRM? A. The regression model is linear in parameters. B. The explanatory variables are stochastic. C. The error term follows a normal distribution. D. The dependent variable is nonlinear. Answer A. Green square explanation. The model must be linear in parameters, e.g., y equals beta plus beta 2x plus u, where beta and beta 2 appear linearly. Q3. The second assumption of CLRM states that A. The error term has zero mean value. B. The dependent variable has zero mean value. C. The independent variables are constant. D. The model has no intercept term. Answer A. Green square explanation. E. U underscore I equals 0. This means on average, the error term has zero effect. Q4. The assumption E, U underscore I, X underscore I, equals 0, implies that A, X and U are correlated. B, X and U are uncorrelated. C, X causes U to change. D, U depends on Y. Answer B. Green square explanation. There should be no correlation between the error term and the explanatory variable, otherwise, OLS estimates will be biased. Q5. Which of the following assumptions ensures no heteroskedasticity? A. Var, U underscore I, equals sigma superscript 2. B. E, U underscore I, equals 0. C. E, U underscore I, U underscore J, equals 0. D. E, X underscore I, U underscore I, equals 0. Answer A. Green square explanation. This states that the variance of the disturbance term, U underscore I, is constant across all observations. Q6. If the assumption of homoskedasticity is violated, what problem arises? A. Autocorrelation. B. Multicollinearity. C. Heteroskedasticity. D. Endogeneity. Answer C. Green square explanation. Heteroskedasticity occurs when the variance of the error term changes across observations. Q7. The assumption of no autocorrelation is written as A. E, U underscore I, equals 0. B. E, U underscore I, U underscore J, equals 0. 4. I is not equal to J. C. Var, U underscore I, equals sigma superscript 2. D. E, X underscore I, U underscore I, equals 0. Answer B. Green square explanation. This means the error terms are independent from one observation to another. Q8. Which assumption ensures that explanatory variables are fixed in repeated sampling? A. Linearity. B. No multicollinearity. C. Fixed X assumption. D. Normality. Answer C. Green square explanation. It assumes that the values of X underscore I are non-stochastic and measured without error. Q9. The seventh assumption of CLRM, no multicollinearity, implies A. The independent variables are perfectly correlated. B. The independent variables are not perfectly correlated. C. The dependent variable is constant. D. The error term is not random. Answer B. Green square explanation. If the independent variables are perfectly correlated, OLS cannot estimate unique coefficients. Q10. The eighth assumption requires that A. The error term is normally distributed with mean 0 and constant variance. B. The independent variables are normally distributed. C. The dependent variable is normally distributed. D. The model has no constant term. Answer: A. Green square explanation. This normality assumption allows for valid t-tests and f-tests in hypothesis testing. Q11. Under all the CLRM assumptions, the OLS estimators are: A. Consistent, only B. Efficient but not unbiased, C. Best linear unbiased estimators, blue, D. Inconsistent and biased, answer, C. Green square explanation. According to the Gauss-Markov theorem, OLS estimators are blue under the classical assumptions. Q12. Which of the following violations affects the efficiency but not unbiasedness of OLS estimators? A. Multicollinearity, B. Heteroskedasticity, C. Nonlinearity, D. Endogeneity, answer, B. Green square explanation. Heteroskedasticity does not bias OLS coefficients but makes them inefficient, less precise. Section 5. Properties of OLS estimators under normality assumption. When the disturbance term, U_I, is normally distributed with mean 0 and variance, sigma caret 2, the OLS estimators possess the following three key properties: unbiasedness, efficiency, minimum variance, consistency. Q1. Under the CLRM, the OLS estimators are considered unbiased because A. They are always equal to the population parameters. B. Their expected values equal the true population parameters. C. They have zero variance. D. They are based on large samples only. Answer: B. Green square explanation. E. Beta equals beta. This means the estimator, on average, gives the correct parameter value. Q2. Which of the following conditions must hold for OLS estimators to be efficient? A. The error term must be homoscedastic and uncorrelated. B. The error term must follow a chi-square distribution. C. The dependent variable must be normally distributed. D. The independent variables must be standardized. Answer: A. Green square explanation. If var U_I equals sigma caret 2 and COV U_I equals 0, OLS estimators have the minimum variance among all linear unbiased estimators, making them blue. Q3. The normality assumption is mainly required for A. Ensuring the model is linear in parameters. B. Conducting valid hypothesis tests, T and F tests. C. Making OLS estimators unbiased. D. Eliminating multicollinearity. Answer: B. Explanation. Normality of U_I allows us to use the T distribution and F distribution for statistical inference. Q4. If the normality assumption does not hold, OLS estimators remain A. Biased but consistent, B. Unbiased but inefficient in small samples, C. Inconsistent and biased, D. Unbiased and efficient. Answer: B. Explanation. Without normality, OLS estimators are still unbiased, Gauss-Markov theorem, but T and F tests become invalid in small samples. Q5. Which of the following best defines consistency of an estimator? A. It produces the same result for every sample. B. As sample size increases, it converges to the true population value. C. It has the smallest possible standard error. D. It follows a normal distribution. Answer: B. Explanation. Mathematically, beta as n infinity. Q6. The three major properties of OLS estimators under the normality assumption are A. Unbiasedness, linearity, normality. B. Consistency, efficiency, unbiasedness. C. Homoscedasticity, independence, normality. D. Linearity, consistency, correlation. Answer: B. Q7. Which of the following is not a property of OLS estimators under normality? A. Efficiency. B. Unbiasedness. C. Heteroskedasticity. D. Consistency. Answer: C. Q8. Why do we employ the normality assumption in regression analysis? A. To make the model easier to calculate. B. To validate inference procedures such as hypothesis testing. C. To ensure X and Y are perfectly correlated. D. To eliminate serial correlation. Answer: B. Explanation. Normality is essential when applying t-tests, f-tests, and confidence intervals on OLS coefficients. Q9. If the error terms are normally distributed, then the OLS estimators are also A. Normally distributed, B. Skewed to the right, C. Biased downward, D. Log normally distributed. Answer, A. Explanation. OLS estimators are linear functions of the error term. If U_I \sim n 0, sigma caret 2, then beta n, beta, bar, beta. Q10. Under the normality assumption, OLS estimators are the same as A. Weighted least squares, WLS, estimators, B. Maximum likelihood, ML, estimators, C. Generalized method of moments, GMM, estimators, D. Rich regression estimators. Answer, B. Explanation. When the error term is normal, the OLS and maximum likelihood estimators, MLE, coincide. Section 6, Maximum Likelihood Estimation, MLE, of the two-variable regression model. This section explores how the maximum likelihood, ML, method estimates the regression parameters, beta_1, beta_2, and sigma caret 2, assuming that the error terms, U_I, and hence, Y_I, are normally distributed and independent. Concept summary. The two-variable regression model is Y_I equals beta_1 plus beta_2x_I plus U_I. Assume that U_I\sim n 0, sigma caret 2, and that all U_I s, and thus Y_I s, are independent. The joint probability density function, PDF, of Y_1, Y_2, Y_n, is then F, Y, Y2, Y beta, beta 2, sigma superscript 2, equals pi, 1 slash square root, 2 pi sigma superscript 2, times exp, minus, Y minus beta 2x, superscript 2 slash, 2 sigma superscript 2. This function is known as the likelihood function, LFL, beta, beta 2, sigma superscript 2, equals, 1 slash square root, 2 pi sigma superscript 2, times exp, minus, 1 slash 2 sigma superscript 2, sigma, Y minus beta 2x, superscript 2. Taking the natural logarithm, for easier differentiation ln L equals, n slash 2, ln, 2 pi, n slash 2, ln, sigma superscript 2, 1 slash, 2 sigma superscript 2, times sigma, e beta 1 beta 2 she, superscript 2. The parameters, beta_1, beta_2, and sigma caret 2, that maximize this log likelihood function are the maximum likelihood estimators, MLEs. Q1. Which of the following assumptions is necessary for applying maximum likelihood estimation, MLE, in the two-variable regression model? A. U_I follows a Poisson distribution. B. U_I follows a normal distribution with constant variance. C. U_I are heteroscedastic and correlated. D. U_I has a mean equal to 1. Answer, B. Explanation. MLE assumes normality and independence of the error term. Q2. The likelihood function, L, beta_1, beta_2, sigma caret 2, represents A. The probability of obtaining the observed sample data given certain parameter values. B. The cumulative frequency of the observed data. C. The sample mean of Y and X. D. The covariance between Y and X. Answer, A. Q3. The logarithmic form of the likelihood function is often used because A. It changes the signs of the parameters. B. It simplifies the differentiation process. C. It removes the parameters from the equation. D. It increases the number of observations. Answer, B. Explanation. Taking logs turns products into sums, which makes differentiation straightforward. Q4. Maximizing the log likelihood function with respect to beta_1 and beta_2 yields A. Weighted least squares estimators. B. The same normal equations as an OLS. C. Different equations with no closed-form solution. D. Rich regression estimators. Answer, B. Explanation. Under normality, MLE of beta_1, and beta_2 gives the same results as OLS estimators. Q5. The likelihood function in the normal regression model is given by a L equals 2 pi sigma caret 2 caret n backslash sum y_I beta_1 beta_2 x_I caret 2 b L beta 2 sigma superscript 2 equals 1 slash square root 2 pi sigma superscript 2 times exp minus 1 slash 2 sigma superscript 2 sigma y minus beta 2x superscript 2 c L equals backslash sum y_I beta_1 beta_2 x_I caret 2 d L equals 2 pi sigma caret 2 caret n slash 2. Answer B. Q6. The log likelihood function for the normal regression model can be written as a ln L equals minus n slash 2 ln 2 pi minus n slash 2 ln sigma superscript 2 minus 1 slash 2 sigma superscript 2 sigma y minus beta 2x superscript 2b backslash ln L equals backslash frac 1 sigma caret 2 backslash sum y_I beta_1 beta_2 x_I c backslash ln L equals backslash ln sigma caret 2 plus backslash sum y_I beta_1 beta_2 x_I d backslash ln L equals y_I beta_1 beta_2 x_I caret 2. Answer A. Q7. Under the assumption of normality, MLE and OLS estimators of beta_1 and beta_2 are A. identical, B. opposite in sign, C. biased, D. independent. Answer A. Explanation: both minimize the same sum of squared residuals, hence yield identical coefficient estimates. Q8. What is the MLE of the error variance, sigma caret 2, in the two-variable regression model? A. Backslash frac, backslash sum, y_I beta_1 beta_2 x_I caret 2, n2, b sigma, y minus beta 2x, superscript 2 slash nc, backslash sum, y_I beta_1 beta_2 x_I d, backslash sqrt, backslash sum, y_I beta_1 beta_2 x_I caret 2. Answer B. Explanation: under MLE, the denominator is n, not n2, as in OLS, making the MLE of variance slightly biased in small samples. Q9. The term exp in the likelihood function refers to a logarithm b exponential function e raised to a power c product sign d expectation value. Answer B. Explanation: exp means e caret x, the exponential of the expression inside the parentheses. Q10. The key idea of maximum likelihood estimation is to a. minimize the squared residuals, b. maximize the probability of observing the given sample, c. minimize sample variance, d. equalize the residuals. Answer B. Section 7, Normality Tests and Diagnostics, MCQs. 1. Which of the following is the main reason for testing the normality of residuals in a regression model? A. To check whether the slope coefficient is 0. B. To ensure that OLS estimators remain unbiased. C. To validate the use of t-tests and f-tests for inference. D. To determine the number of explanatory variables to include. Answer C. 2. A histogram of residuals is mainly used to a. compute the R superscript 2 value of a regression, b. visually check whether residuals are normally distributed, c. identify multicollinearity between variables, d. test for autocorrelation. Answer B. 3. In a normal probability plot, Q plot, if residuals follow a straight 45 degrees line, it implies a. homoscedasticity, b. normality, c. multicollinearity, d. heteroscedasticity. Answer B. 4. Which of the following tests is a formal statistical test for normality? A. Durbin-Watson test, b. Brush-Pagan test, c. Jarque-Bera test, d. Goldfeld quant test. Answer C. 5. The Jarque-Bera (JB) test is based on which two statistical measures? A. Mean and variance. B. Skewness and kurtosis. C. Correlation and covariance. D. Standard deviation and range. Answer B. 6. If the calculated J-B statistic is greater than the critical chi-square value, we A. Accept the null hypothesis of normality. B. Reject the null hypothesis of normality. C. Fail to reject the null hypothesis. D. Conclude that residuals are homoscedastic. Answer B. 7. Which of the following is a subjective method of testing for normality? A. Jarque-Bera test. B. PP plot. C. Histogram of residuals. D. Shapiro-Wilk test. Answer C. 8. The normality assumption is particularly important for A. Estimation of coefficients. B. Hypothesis testing and confidence interval. C. Detecting multicollinearity. D. Computing residual sums of squares. Answer B. Direct hit section 7 and 8. Normality tests and diagnostics, MCQs. 1. Which of the following is the main reason for testing the normality of residuals in a regression model? A. To check whether the slope coefficient is 0. B. To ensure that OLS estimators remain unbiased. C. To validate the use of t-tests and f-tests for inference. D. To determine the number of explanatory variables to include. Answer C. 2. A histogram of residuals is mainly used to A. Compute the R superscript 2 value of a regression. B. Visually check whether residuals are normally distributed. C. Identify multicollinearity between variables. D. Test for autocorrelation. Answer B. 3. In a normal probability plot, QQ plot, if residuals follow a straight 45 degrees line, it implies A. Homoscedasticity. B. Normality. C. Multicollinearity. D. Heteroscedasticity. Answer B. 4. Which of the following tests is a formal statistical test for normality? A. Durbin-Watson test. B. Brush-Pagan test. C. Jarque-Bera test. D. Goldfeld quant test. Answer C. 5. The Jarque-Bera (JB) test is based on which two statistical measures? A. Mean and variance. B. Skewness and kurtosis. C. Correlation and covariance. D. Standard deviation and range. Answer B. 6. If the calculated J-B statistic is greater than the critical chi-square value, we A. Accept the null hypothesis of normality. B. Reject the null hypothesis of normality. C. Fail to reject the null hypothesis. D. Conclude that residuals are homoscedastic. Answer B. 7. Which of the following is a subjective method of testing for normality? A. Jarque-Bera test. B. PP plot. C. Histogram of residuals. D. Shapiro-Wilk test. Answer C. 8. The normality assumption is particularly important for A. Estimation of coefficients. B. Hypothesis testing and confidence interval. C. Detecting multicollinearity. D. Computing residual sums of squares. Answer B. Direct hit section 9. Multicollinearity, concept, causes, effects, and detection tests, MCQs. 1. Multicollinearity occurs when A. The dependent variable is correlated with the error term. B. Independent variables are highly correlated with each other. C. The error terms are correlated across observations. D. The residuals have unequal variances. Answer B. 2. Which of the following is a possible cause of multicollinearity? A. Inclusion of irrelevant variables. B. Exclusion of important variables. C. Linear relationships among explanatory variables. D. Nonlinear relationships among residuals. Answer C. 3. A major consequence of multicollinearity is A. Bias in OLS coefficients. B. Increase in standard errors of coefficients. C. Reduction in R superscript 2 value. D. Autocorrelated residuals. Answer B. 4. Which of the following statements about multicollinearity is true? A. It makes OLS estimators biased. B. It affects the efficiency and precision of estimates. C. It causes heteroscedasticity. D. It always invalidates regression results. Answer B. 5. When perfect multicollinearity exists, A. OLS estimation is still possible. B. OLS estimation is impossible because XX cannot be inverted. C. The regression model becomes nonlinear. D. The model automatically adjusts through dummy variables. Answer B. 6. A high or superscript 2 value but few significant t-values in a regression model often suggests A. Autocorrelation, B. Multicollinearity, C. Heteroscedasticity, D. Specification error. Answer B. 7. Which of the following can be used to detect multicollinearity? A. Durbin-Watson statistic, B. Variance inflation factor, VIF, C. Brush-Pagan test, D. Jarque-Bera statistic. Answer B. 8. A VIF value greater than 10 generally indicates A. Low correlation between regressors, B. Serious multicollinearity problem, C. Non-normal residuals, D. Correct model specification. Answer B. 9. One practical way to reduce multicollinearity is to A. Add more correlated variables, B. Transform variables into logarithms or differences, C. Remove the dependent variable, D. Increase the error variance. Answer B. 10. The tolerance value, used in multicollinearity detection, is defined as A1/VIF, B. VIF times R superscript 2C, R superscript 2, 1D square root VIF. Answer A. Direct hit section 10, Heteroscedasticity, Concept, Causes, Consequences, and Tests, MCQs. 1. Heteroscedasticity occurs when A. The variance of the error term is constant across observations, B. The variance of the error term changes with the level of an explanatory variable, C. The mean of the error term is not 0, D. The residuals are serially correlated. Answer B. 2. If the variance of the error term is the same for all observations, the data are said to be A. Heteroscedastic, B. Homoscedastic, C. Autocorrelated, D. Multicollinear. Answer B. 3. Which of the following is a common cause of heteroscedasticity? A. Inclusion of irrelevant variables, B. Omission of a relevant variable, C. Presence of outliers or large differences in scale of data, D. Perfect multicollinearity. Answer C. 4. Heteroscedasticity violates which OLS assumption? A. Linearity, B. Normality of residuals, C. Constant variance of the error term, D. Independence of explanatory variables. Answer C. 5. The major consequence of heteroscedasticity is A. OLS estimators become biased, B. OLS estimators remain unbiased but inefficient, C. R superscript 2 becomes 0, D. Dependent variable changes its mean. Answer B. 6. Which of the following tests is not used to detect heteroscedasticity? A. Goldfeld, quant test, B. Brush-Pagan test, C. White's general test, D. Durbin-Watson test. Answer D. 7. The Brush-Pagan test is based on the assumption that heteroscedasticity is a function of A time B. The fitted values of the dependent variable, C. The independent variables, D. The error term itself. Answer C. 8. Which method can be used to correct heteroscedasticity? A. Weighted least squares, WLS, B. Ridge regression, C. Adding more variables, D. Increasing sample size. Answer A. 9. Which of the following is true about heteroscedasticity? A. It always biases the regression coefficients, B. It causes the standard errors of estimates to be unreliable, C. It increases R superscript 2 artificially, D. It implies perfect collinearity. Answer B. 10. The White test for heteroscedasticity is preferred because A. It assumes a specific form of heteroscedasticity, B. It is applicable even when the form of heteroscedasticity is unknown, C. It is used only in time series data, D. It is easier than OLS. Answer B. Direct hit section 11, Autocorrelation, Concept, Causes, Consequences, and Tests, MCQs. 1. Autocorrelation occurs when A. Error terms are correlated with explanatory variables, B. Error terms are correlated with each other across observations, C. Independent variables are correlated with each other, D. Variance of residuals is not constant. Answer B. 2. Autocorrelation is most common in A. Cross-sectional data, B. Time series data, C. Panel data, D. Experimental data. Answer B. 3. The first-order autocorrelation assumes that A. Each error term depends on the square of the previous one, B. Each error term depends linearly on the previous error term, C. Each error term depends on the independent variable, D. Each error term is independent. Answer B. 4. Which of the following is a major cause of autocorrelation? A. Data smoothing or inertia in time series. B. Omission of relevant variables. C. Inclusion of irrelevant variables. D. Measurement error in X. Answer A. 5. A positive autocorrelation implies that A. Successive residuals tend to have opposite signs. B. Successive residuals tend to have the same sign. C. There is no correlation between residuals. D. Errors are normally distributed. Answer B. 6. The Durbin-Watson (DW) statistic is used to test for A. Multicollinearity. B. Heteroscedasticity. C. Autocorrelation. D. Non-normality. Answer C. 7. If the Durbin-Watson (DW) statistic is almost equal to 2, it indicates A. Positive autocorrelation. B. Negative autocorrelation. C. No autocorrelation. D. Perfect correlation. Answer C. 8. When DW2, it generally suggests A. Negative autocorrelation. B. Positive autocorrelation. C. No autocorrelation. D. Model misspecification. Answer B. 9. One possible way to detect autocorrelation graphically is by A. Plotting residuals against predicted values. B. Plotting residuals against time. C. Plotting residuals against independent variables. D. Plotting actual Y against estimated Y. Answer B. 10. A consequence of autocorrelation in a regression model is that A. OLS estimators become biased and inconsistent. B. OLS estimators remain unbiased but inefficient. C. Variance of estimators is unaffected. D. R superscript 2 decreases automatically. Answer B. 11. Which of the following methods can help correct autocorrelation? A. Weighted least squares, WLS. B. Generalized least squares, GLS. C. Ordinary least squares, OLS. D. Two-stage least squares, 2SLS. Answer B. 12. If autocorrelation is detected, one common remedy is to A. Transform the variables logarithmically. B. Include lag-dependent variables as regressors. C. Remove all correlated variables. D. Reduce the sample size. Answer B. 13. In the presence of autocorrelation, the OLS standard errors, A. Are smaller than the true values. B. Are larger than the true value. C. Remain the same. D. Become 0. Answer A. 14. Which of the following tests can also be used for detecting autocorrelation in large samples? A. White test. B. Brush-Godfrey test. C. Goldfeld, quant test. D. Ramsey reset test. Answer B. 15. A negative autocorrelation implies that A. Positive errors tend to follow positive errors. B. Negative errors tend to follow negative errors. C. Positive errors tend to follow negative errors. D. Errors are uncorrelated. Answer C. 16. Autocorrelation leads to A. Overestimation of t-statistics. B. Underestimation of t-statistics. C. Both over- and underestimation depending on the sign. D. No effect on t-statistics. Answer C. Small blue diamond. Section 12, Heteroscedasticity, 10 MCQs. Q1. What is heteroscedasticity in a regression model? A. When the error terms have constant variance. B. When the error terms have non-constant variance. C. When the error terms have zero mean. D. When the explanatory variables are correlated. Answer B. Q2. Heteroscedasticity violates which classical regression assumption? A. Linearity in parameters. B. No autocorrelation. C. Homoscedasticity of errors. D. Normality of variables. Answer C. Q3. What is the major consequence of heteroscedasticity in OLS estimation? A. OLS estimators become biased. B. OLS estimators lose consistency. C. OLS estimators remain unbiased but inefficient. D. OLS estimators become inconsistent and biased. Answer C. Q4. In the presence of heteroscedasticity, the OLS estimators are A. Blue. B. Still linear and unbiased but not efficient. C. Nonlinear and biased. D. Consistent but not linear. Answer B. Q5. Which of the following tests can be used to detect heteroscedasticity? A. Durbin-Watson test. B. Brush-Pagan test. C. Jarque-Bera test. D. Chow test. Answer B. Q6. Which graphical method is most commonly used to detect heteroscedasticity? A. Scatter plot of residuals versus fitted values. B. Histogram of residuals. C. QQ plot. D. Time series plot of Y. Answer A. Q7. One common cause of heteroscedasticity in cross-sectional data is A. Autocorrelation. B. Large variations in the size of the sampled units. C. Serial correlation. D. Data transformation errors. Answer B. Q8. Which of the following methods can be used to correct heteroscedasticity? A. Using weighted least squares, WLS. B. Ignoring the problem. C. Using unweighted OLS. Always. D. Increasing the sample size. Answer A. Q9. Which of the following statements is true about heteroscedasticity? A. It affects the unbiasedness of OLS estimators. B. It affects the efficiency and validity of hypothesis tests. C. It affects both unbiasedness and consistency. D. It has no effect on OLS estimators. Answer B. Q10. The presence of heteroscedasticity leads to A. Overestimation of t-statistics. B. Underestimation of standard errors. C. Wrong inference from hypothesis tests. D. All of the above. Answer D. Bell. Don't forget to thumbs up like this video if you find it helpful. Envelope with arrow. Comment your score or topic suggestions below. Book. Subscribe for more noun related exam guides and summaries. 3 o'clock. Watch next ECO355 summary notes and exam past questions.